If you've got an existing LangChain agent that works, it's got all of the functionality, the tool calling, the workflows that you need, but you just want to add voice to that agent without starting all over again from scratch, then I've got a solution for you. So this is the LiveKit LangChain plugin, and it's going to present you with a single API surface, an LLMAdapter, that will wrap your LangGraph and enable you to add it into the LiveKit audio pipeline. So you get audio in through WebRTC in real time to your unchanged LangChain agent, and then audio out again over WebRTC to any of our supported clients. Now there's 3 different ways of integrating with the plugin. You can bring your existing LangChain StateGraph, you can bring a LangChain agent, or you can bring a LangChain Deep Agent. And I'm going to walk through each of those 3 right here. Starting off then with the LangGraph StateGraph. So this is taking in an agent state that I've defined, keyed on messages. That's very important. It's fairly standard, but it is a requirement of the plugin that you use messages. There's an add messages reducer to make sure that new conversation history is added to the history rather than replacing the old history. The graph itself is fairly simple. It's just a single node called model, and we've defined this to prepend any agent instructions, and then we add in the latest messages. We pass that in to the LLM, so OpenAI in this case, and then we return the response again keyed on messages. With that node, we add the start and the end, and we return the compiled graph. So with that graph, we'll go down here. This is a standard LiveKit agent session definition. Everything is the same, so turn handling, STT, TTS, exactly as you'd find in any other LiveKit agent, but this is where the magic happens. In your LLM, you're defining the LLMAdapter. This is going to convert all of the LangChain messages, so your human messages, your AI messages, system messages, into LiveKit chat messages, chat context. So let me show you what this looks like. I've got my agent here deployed into LiveKit Cloud. I'm going to run it in our new agent console, and I can start a session and ask the AI, what's the capital of Chile?
The capital of Chile is Santiago. Anything else you want to know about Chile or its cities?
And there you go. You see the time to first token is sitting around half a second, so fairly good. Let's have a look at LangChain Agents. Back in the IDE then, and this time it is a complete LangChain agent, albeit a fairly simple one. It's being returned from the Create Agent API, which is part of the LangChain SDK. We're passing in the same OpenAI model as before, but this time we're also giving the agent access to a LangChain tool. Here it's the fairly standard get weather stubbed tool just to show the principle, but this could be any LangChain tool that you have already defined in your agent. The return value of Create Agent is a compiled StateGraph, so that will still be compatible with the LiveKit plugin LLMAdapter that I was discussing previously. There is one caveat worth pointing out here in that when you use these LangChain agents with tools, they will output all of the tool state as it's calling the tool. You don't want your TTS to be speaking all of those tool state messages. So what I'm doing, I'm using the LLM node, which is a concept in LiveKit, to hook into the LLM and only tell it to allow AI message chunks to proceed. That just means that your user is only going to hear the messages that you want them to hear in your TTS. And then down in the agent session, everything hooks up exactly the same as before. The compiled graph is passed into the LLMAdapter, and that becomes your LLM node in your LiveKit pipeline. And let's see a demo of that. We've got our LangChain agent deployed to our LiveKit console. I'll just start a session using our agent console and ask, what's the weather in London, please?
The weather in London is sunny and 72 degrees Fahrenheit.
Okay, thank you. So that was the result from the tool call. And if I look into the TTFT, you'll see that this one was just over a second. And finally, the LangChain Deep Agent. This is the most capable of the agent types I was talking about today. It's actually going to plan a trip for us. Well, for me. So it's going to break the task down into a number of to-dos. It's going to delegate weather research to a subagent. So let me just show you what that looks like. So we're using the same model, OpenAI model, as before. We have a subagent, which is going to be our weather researcher, has access to the same get weather tool that I used in the previous example. But here, the deep agent parent has access to a get attractions tool, again, a separate LangChain tool, and that's just going to have a basic list of attractions it can do in each of these supported cities. The key thing to note is that Create Deep Agent, this LangChain SDK API, will still return a compiled state graph. So that's the same type as we were talking about in the two previous examples, still compatible with the LiveKit LLMAdapter. And again, similarly with the previous example, the tool calls, you don't want each step of that tool call being spoken out loud. So I again use the LLM node to capture and pass through only the AI message chunks. Again, the actual integration with LiveKit at the agent session level just replaces the LLM with a call to the LLMAdapter with your compiled graph. And again, that code has been uploaded to an agent running in LiveKit Cloud, so we can demo that here. Please plan a trip to Paris for tomorrow for me.
The weather in Paris tomorrow will be sunny with a temperature around 72 degrees Fahrenheit and...
Thank you very much. Okay, so I just let it talk because I needed the conversation item added event just down here to show you the time to first token. It's quite long, and it's almost like I put this demo together to illustrate a point. So let's go back to the documentation, and I'll give a little bit of a talk about latency. So latency is the biggest thing that I see tripping up users when they add voice to their LangChain agents. Now, frequently, existing agents were designed for a text environment where 6 or 7 seconds response time was considered perfectly okay. But in a voice environment, I mean, you saw in that example just now, the deep agent took that long to respond and it felt like a really poor experience. So you're going to need to, if not completely rewrite your agent, which I presume you don't want to do, make a few minor modifications to improve that end user experience. You could do things like modifying your system prompt to contain instructions like be concise or do not include bullet points or emoji in your answers. That can really improve your end user experience. Or from the LiveKit side, we support RPC, remote procedure call, so you're able to display a progress bar maybe on the user's UI. We can play thinking sounds, maybe like a keyboard tapping sound in the background. The LLM's obviously not really typing on a keyboard, but it just feels to the end user like something is happening and they're not just sat there in silence waiting for a response. Similarly, just setting up expectations before the agent does any research. It could say, I am just looking that up for you, and then the user is more than happy to wait a few seconds because they understand that something is happening in the background. So I want the takeaway from this video to be, absolutely, you can take your existing LangChain agent and add voice to it with very minor modifications and have a production-ready voice agent ready to go based on your existing LangChain workflows. Hopefully you found this video useful. I'll include links to all of the resources, including the code in the description down below. If you had any other questions or you just wanted to chat, feel free to swing by our developer community at developer.livekit.io. If you really like the video, we'd appreciate a like and subscribe. But other than that, I've been Darren. Thank you very much for watching.